In this presentation, we're going to continue on with the domain and range of functions. So I've done a few already, so I'm just going to sort of continue with this set. But before I'm going to continue, I'm just going to remark upon the domain and range of sine x and cos x. Okay, these are special cases. Okay, so sine x and cos x. Okay. The domain is any real number, so you can supply any real number to these commands, okay? So that's straightforward enough. So, as we might write it here, minus infinity to infinity, okay? Or, in other words, any real number, okay? That's Blackboard font. That's not IR, it's actually just R with the sort of double... Oh, yeah, that's it there. That's called Blackboard font. Now, anyway, the domain is straightforward enough. Any real number. This is the important part. This is the important part for sine and cos. That the output will always be between minus 1 and 1. You can try that in your calculator. No matter what you do, the output of a function, like cos of minus 1,000 or cos of 1,000 or sine of minus 1,000, whatever, the values will always be between minus 1 and 1. Now, I could sort of put more of an explanation onto that, but I won't for the sake of brevity. Just to remark, the output of a trigonometric function, cos and sine, will always be between minus 1 and 1, inclusive. Just again to remark upon the square brackets, which means inclusive. So anyways, I'll just get back to the questions now. This is the fourth of the questions. State the domain and range of the following functions. Well, I've sort of stated this one already. Okay, so that is, again, let's just go back there. Minus infinity to infinity as the domain, and minus 1 to 1 inclusive as the range. Okay, now g of x is a little bit different. Okay, so I'll move on to g of x straight away. So, just to sort of remark that the sine, we have sine of x here. Now, the output of that is always going to be between minus 1 and 1. Okay? So, what happens when we multiply that by minus 2? Essentially, if we get an output as low as minus 1 here, or as high as plus 1, essentially when we multiply by 2, or minus 2, we get 2 and minus 2. So, the actual overall range of g of x is minus 2 to 2. Okay? So, that's it really. Moving on to the next one, state the domain and range of the following functions. Okay, in this case, again, it is the domain is f of x, domain is minus infinity to infinity, and the range, again, just to state it out, it is minus 1 to 1 inclusive. Okay. Now, g of x is f of x squared. Okay. Now, so what happens when we get f of x equal to minus 1? So actually, I'll just sort of state that this is actually f of x squared. Okay, you might notice that. So what happens when we get an output of minus 1? Well, g of x, will we get minus 1 squared, okay, which is be 1. If we have an output of f of x equals 1, square that, we get 1 as well, okay. Essentially what I'm saying is that this, when we have a squaring term here, okay, we always get a positive answer, okay, and the answer cannot exceed 1, okay, so all the inputs are of this part are between minus 1 and 1, okay. So essentially the domain, or the domain is any real number, okay, but the range has to be greater than 0, okay. The lowest possible value here is 0, the highest possible value here is 1, okay, because when we get minus 1 squared, we get 1, so the lowest possible value we can get is an output of f of x equals 0, so 0 squared equals 0. Okay. Okay, that's that part. And now this is a more interesting one, actually. I'll probably, okay, so I'll do it here now. So, f of x e to the x, okay. So what I'm going to sort of say is, suppose we have I'm going to give two examples here. E squared, okay. You work it out in your calculator, you would get some value there, like 7 point, I don't remember what it was, but essentially it's greater than 0, okay. Now what happens if you put in e to the minus 2? Okay, so let f of x, sorry, my notation's gone a bit wonky there. F of minus 2 equals e to the minus 2 squared, okay, or e to the 2. Okay, so what happens if we have f of minus 2? That is equal to e to the minus 2. Okay, now let's look at that. That is can be rewritten as follows. Okay, now we already know that this is positive. Okay, so that part has to be positive. So overall, what can we say? Well, we have a positive number over a positive number. Okay, so that it can be positive. It cannot equal 0. So it's positive. It can be positive. It can't equal 0. And the reason it can't equal 0 is because if it equals 0, the numerator, the top bit, has to equal 0, where it can't because the numerator here is 1, and it can't be negative. Okay, because we don't have a negative number on top, we can't have a negative number below. So it can't equal 0 or be negative. Okay, so it can only be positive, essentially, is what I'm saying. So in this case, we can input any value. Okay, minus infinity to infinity. So the domain here, I'll just scroll back up, or I'll just cut this bit out and do it here. The domain is any negative number, or any positive number, or 0. So the domain is essentially all real numbers. Now the range is the possible outputs. Now, we can get a value close to 0. We can put in a really, really large input here for x of something like that, and we get 1 over e to the 1000, or whatever, which will be very close to 0, but not equal to 0. Okay, so essentially what I'm saying is we can have a value very, very close to 0, but not equal to 0. Okay, and up all the way up to infinity. So this is an important one because it cannot take the value 0. The range, this output cannot take the value 0. We can have any input, but we can't have an output of 0 or less than 0. We're going to have a positive number output. Positive number in output. Yeah. So that is that one there. Now the other one is fairly similar. Essentially, e to the x minus 2. So you can get a value close to 2. So essentially, for this one, the g of x, it's essentially you can get e of x, you can get a value close to 0, and then subtract 2. So the domain is, you can have any input in the real number from the real numbers, and the range is minus 2 to infinity. So really, really massive number as the input, as x, or a really, really high number there. Sorry, I made a mistake here. This should be f minus 1000 or 10,000 or 100,000. So a little mistake there. Essentially, really, really large negative number. Okay, or large in terms of absolute value, will give you a value close to 0, and then you subtract 2. But it cannot equal to 2, the output. Anyway, that is it. That's a bit of a long-winded explanation. I'm going to leave it there.